Hello, my name is Nikki Roberts, and today I will be providing you a topical brief on how upstream oil and gas companies can leverage big data for purposes of predictive maintenance. Exploration and production oil and gas companies are no strangers to utilizing large quantities of data to shape their operations. During the exploration process, geologists use large volumes of seismic data to determine subsurface resources. These determined resources are more fully analyzed and the value is quantified during the development stage. To model and determine the worth of a reservoir, engineers and geologists must rely on a variety of data. Finally, the sensor data is generated and analyzed during the drilling and production phases of well development and can be characterized by their velocity as data is streamed and analyzed in real time. This data is generated directly from wellheads and drilling equipment and is the focus of today's brief. McKinsey & Company published an article in August of 2014, which included a survey of experts and their own analysis. This survey concluded that the highest impact automation opportunities for upstream oil and gas producers were found primarily in their production operations. Specifically, among those were opportunities to improve reliability and preventative maintenance for their equipment. This image displays a typical hydraulic fracturing crew that is working to complete the drilling of a well and move it to its production stage. The different types of equipment are pointed out in this image, but within each type of equipment, the wellhead or frac pump, for example, there are a multitude of different mechanical parts that are oftentimes now included in some type of data gathering device. This may be SCADA data that is monitoring data sets like temperature or pressure, or it could be operational devices that can use data captured by these devices to automate certain actions. For example, shutting down a process if a certain threshold is breached. It is easy to see in this picture that the recovery process for an oil and gas producer is made up of a lot of moving parts. Now imagine that this well is part of a 6 or 8 well pad and that there are a multitude of producers in this area, and the location is a remote part of, let's say, West Texas. This makes the maintenance of this equipment quite challenging. At the same time, preventative maintenance is on this very expensive equipment can be the difference between a successful operator or service provider and someone who will not be able to recover on their investment. The solution is to leverage existing data to provide predictive analytics. These types of systems can analyze data coming directly from the equipment in the form of SCADA data, along with other industry standard data points as well as regulatory items to form a comprehensive maintenance plan and schedule. By looking for patterns in product degradation and failures, this system can prevent downtime, optimize field scheduling in conjunction with various other tasks taking place on site, and improve maintenance and planning for a resource allocation and financial perspective. At the end of the day, you want to ensure that the people going to these sites are exactly where you need them to be, and they're out of the way if you don't need them to be on site. So now let's dive into how preventative maintenance systems are formed. In terms of the big data world, this starts with Hadoop. Hadoop is an open source platform built by Apache that helps provide a foundation for systems to process and store the ever-increasing amount of data at high speeds. The two fundamental aspects of this system is processing and analyzing data and the storage of data. Unlike traditional structured data that performs well in relational databases, unstructured data takes much more processing power to generate usable, actionable information. By using the foundation of Hadoop, systems can process pieces of information workloads in parallel rather than one system performing functions from start to finish. Similarly, data can be distributed and stored in a variety of locations. This helps balance workloads among available resources and eliminate single points of failure. MapR is a component of the Hadoop platform which processes the data in parallel and thus generates actionable information at high speeds with the goal of reporting closer and closer to real times. In terms of predictive maintenance solutions, MapR stores and processes real-time and historical data, then ingests, analyzes this data alongside industry information like regulatory items that I mentioned previously, then can proactively learn patterns and behavior that can provide necessary warnings to those managing the systems. This process thus takes data from a multitude of sources and provides the user with information that can lead to necessary business decisions. One potential roadblock to the data collection and processing for preventative maintenance systems is data leakage. An example of this in the oil field is information that can be collected from individual components of equipment rather than looking at assets on site holistically. Additionally, systems oftentimes are set up to capture and predict catastrophic events, but may be unable to report the root cause of the issue. As the illustration suggests, data leakage can exist at all points of the process and thus should be considered when attempting to integrate a data-driven system into a business process. Overall, a successful preventative maintenance system utilizing the latest techniques such as the Hadoop Foundation has the capacity to increase the operational efficiencies of oil and gas companies. While data-driven processes have focused primarily on seismic and reservoir data, there are enormous possibilities for data-driven maintenance processes. These automated processes have the ability to reduce non-productive time, which can translate to millions of dollars in avoided losses, mitigate catastrophic events, which can be life-threatening and pose a great risk to the environment, increase the economic longevity of assets by performing critical proactive maintenance, and finally can narrow the focus of oil and gas employees by putting them at the right place at the right time. Moving forward, another critical thought to consider is the idea of data democratization within an organization. Organizations should strive to share data across functions to extract the most amount of information that is actionable. By taking the processing of data out of a silo and creating a cross-functional team, organizations can maximize the effort of their data-driven processes. Next, organizations must think big in terms of the possibility of process improvements with data analytics, but pilot small to ensure that the process fits their requirements, and scale fast to ensure that as much value is extracted from the data as possible. Finally, organizations must embrace a data-driven culture. Efforts to collect and analyze data is not only time-consuming, it's still often time-expensive. Companies must embrace data analytics in the decision-making process to get the most return on their investment in data analytics. Thank you.